Hello and welcome to my channel. In reference to the Air India Boeing 787 crash, I keep hearing about the battery failure, a battery fire, mainly from experts from India and also from some viewers that have left comments on a few of my videos. So at the beginning, I didn't really pay much attention to this. I didn't see the relationship. Why? Because I thought that everything that had to do with the engines and also the controls, monitoring, everything was voltage supply by the permanent magnet alternators, I think. But by doing a little bit of research, I found this image that you're seeing on the screen right now, which is very basic, but it mentions here on the right side the fuel levers, meaning the fuel run and cutoff switches. And it points to this block here, which says Airplane Common Data Network, CDN. And on this part, it says Airplane 28 volts DC, ignition system, power supply, airplane to EEC, cockpit, start, run, switch, fuel lever. So I think this image is pretty much saying that the fuel levers or fuel control switches control the engines via this network, and the EEC is the one in charge of opening and closing valves. This is what I understand from this image. So I did a little bit more research, and there's pretty much nothing about this system about the fuel switches. But I did find this image, which I think has good information. It's basic, but it has good information. One thing that caught my attention was this part here. The 28 volt DC comes into the fire protection panel for the engines. It continues and it goes to the relay for their spar valve, for the fuel valve for the engines. Okay. And then I saw this line, I follow it, it says run cutoff, and it goes to the fuel cutoff switches. I also saw this line going to this interface, RDC interface, which is basically a translator for input signals, voltage signals, and translate it into a protocol to communicate with other equipment on the airplane. But I noticed that this electrically talking doesn't make much sense. Maybe because whoever did this is just, did a very good job just to present a basic, how basically this stuff is interconnected. So nothing wrong, okay? What I did was try to put it in a way that I think it should show. Let me go here, throttle corrected. Okay. As you can see, I added some voltage lines. So if we focus again on that part, the voltage, 28 voltage DC goes through the fire protection panel, goes down, and it continues to go just like the graphic says to the relay for the fuel valve. But he also supplies the switch for the fuel cutoff switch. That switch, when it's turned to the run position, lets voltage pass and goes through the coil that energizes, closes and opens that relay. So when that switch is put in the run position, it lets voltage pass, energizes that relay, and lets that fuel valve, spar fuel valve, open to let fuel pass to the engine. Okay? Very simple. That switch, when it's turned on, also lets voltage pass to that interface to let most likely the EEC or the all other equipment, that the fuel cutoff valve is in the run or cutoff position. Okay, and this communicates that, I believe, to the, according to this, to the EEC. Yes. Okay. So if this is the way is really connected, which it could be wrong, let's just go through the example analyzing, and maybe we're wrong. I don't know. We're doing it for research purposes. So if this diagram is correct and this is the way it works, man, that is not good. Let me show you a simulation I did, very extremely basic. I apologize to any electricians out there for this diagram, but it's extremely basic to try to everybody understand what I'm going to explain next. So this here in this diagram is supposed to be the battery, the main battery of the aircraft, 28 volts DC or battery bus. This is the main fuel cutoff switch, okay? You can turn it on and off right there. This is the fuel valve relay. This is the fuel spark valve. I'm sorry, I don't have anything else to represent it on this diagram. So I put a label to represent open or close on the fuel valve. And this is the engine, okay? This is the separate voltage supply for the RDC. I don't know if this is correct or no. Maybe they are supplied by the same voltage. It doesn't matter for this example. Now this part here, please, if you can pay attention to this part, this is the remote data concentrator. This is that interface that I mentioned before, RDC. This is the one that detects that signal from the switch, fuel cutoff switch, okay, if it's in the run or cutoff position. And that RDC tells the EEC, hey, let's go, start the engine in run. So let's say that the aircraft, the Air India aircraft is at the terminal. The pilots start the engines, put it in the run, okay, that energizes the relay. That opens that fuel valve, lets fuel into the engine starts. That RDC, okay, gets the signal, listen to this, gets the signal from the fuel switch, okay, that the fuel switch, that famous fuel switch was put in the run position. That RDC communicates it to the EEC and it starts the start engine process. Okay, so far so good. Now, this aircraft is going down the runway, okay? It takes off, and right after liftoff, what does the captain supposedly does? He moved that switch to the cutoff position right after takeoff. The RDC detects that fuel switch was put in the cutoff position. That closes the fuel valve to the engine, and the engine shut down through the EEC, the engine control unit. Okay? So this aircraft is with the engine shut down because the switch was shut down. Now, let's go back to the terminal. Okay? The pilots get into the airplane and they start the engines. Okay? Again, the RDC detects that the switch was put in the on position, relay energizes, the fuel valves open, lets fuel to the engine, and the engine runs. Okay? Everything good? Now, the Air India Boeing 787 is in the takeoff run, lift off, and right after liftoff, look at the RDC signal. Look, this part, what's going to happen. Boom. What happened? My fuel run cutoff switch is in the on position, The RDC detects that the switch was put in the cutoff position, fuel valve closes, engine quits, stops. But how is this possible? The run cutoff switch is still in the run position. If that graphic that we saw before is correct, okay, and this RDC gets a signal, a voltage signal from the switch, if this is how it works, man, this is not good, like I said before. Because this fuel cutoff signal can be simulated or duplicated by cutting voltage to that switch. To make it more a little bit simpler, the RDC, which is the interface that detects if that switch is in the run or cutoff position, has no way, okay, I repeat, has no way of knowing if the switch was moved physically, because that interface is just expecting a voltage signal. It's not expecting a hand moving it up or down. Expects a voltage signal. Okay? So if I move that switch to the off, on, nothing happens. That RDC still detects that the switch is in the off position, in the cutoff. So how to make this work again? You have to supply that voltage to that fuel cutoff switch, and then that RDC is going to see the signal. So that can be duplicated if this graphics is correct. If it's not, and this is not how it works, please forget everything I said, because everything is wrong. But if that graphic is correct and this is how this system works, you know what that means? Wow. Well, basically this part here on the report where it says that the fuel cutoff switches transition, that word, if that graphic is correct, okay, and that connections are correct, this transition word here does not go there, because there is no way to know that the switch was moved or not. Again, I'm going to keep saying it over and over. Everything I said could be wrong, okay? Because I'm not going with the original schematics. I don't have any of that. Nothing of that is available. At least I couldn't find anything on the internet. So everything could be wrong. But again, I repeat, if it's okay, that graphic, and that's how it works, that simulation, how it works, this transition word should not be there. Well, you might be asking, but what could have caused this failure on the voltage, okay, which could have also affected the RDC? If the EEC, which is getting its voltage from the permanent alternator, magnet alternator, is still running, the EEC is working, but then it's not getting any signal from the RDC because it also lost voltage. The EEC has no reference whatsoever for fuel levers, the throttle, handles, and it has no reference for the fuel cutoff switches. So what the EEC does, if I'm not mistaken, shut down the engines. So what could have caused the DC voltage to fail? I'm not saying that this is what happened in Air India Boeing 787, but this is something that happened years back, where some batteries burn on some Boeing 787. I think it was ANA and Japan Airlines. I think this was like 10, 12 years ago. And this is an image of the result of the fire of one of the batteries. This is what the NTSB was investigating. This is how one of the batteries burned. And this is white smoke coming out from the aircraft. Interesting. So again, I'm not saying that this is exactly what happened in this Air India Boeing 787 that crashed. I'm not saying that that's what happened, okay? But I think I just want to put that out there. If anybody, some of the comments on some of my videos, if you're gonna say that I'm an idiot, because of this or that, at least just give me some information, that if you give me a schematic of the throttle quadrant, electrical schematics, and everything that I say is wrong, hey, yeah, I'm an idiot. But just don't write that I'm an idiot and you're not gonna provide any information. Hey, you're wrong. That doesn't work like that. And no information provided, no feedback. Everybody is entitled to their opinion, but I'm just asking if you can provide me with a little bit of information. I like to do investigation and research, especially in this crash. Anyways, thank you for watching. Take care and see you in the next video.